Hello everyone, and welcome to the introduction to research method in psychology. Module 9. The topic of today's lecture is factorial design. Factorial design is being used when an experiment includes more than one independent variable. In this case, independent variables are often called factors. A single combination of levels would be then one condition of our experimental research. For example, we would like to study what type of learning is the most effective. We will have two independent variables, the daytime of learning and the type of method we use when taking notes. Do we use a computer or do we use a notebook? In this case, an old-fashioned one with a paper and pencil. So we have two independent variables. Each independent variable has two levels. So in our experiment, we will have four conditions. Condition A, studying at the morning and using paper and pencil. Condition B, studying in the morning and using computer. Condition C, studying at the evening and using paper and pencil. And condition D, studying at the evening and using a computer. Of course, we can also use a third variable. For example, usage of caffeine. In this case, our experiment would have 8 conditions. Factorial designs can be both between subjects and within subject designs. In case of between subject design, each subject participates in only one condition. In a case of within design, each subject participates in more than one condition. For example, if we would like to use a factorial within design in our experiment, we can ask subject in group A to study both at the evening and at the morning, but use only paper and pencil for taking notes. And subject in the group B would also study at the morning and at the evening, but use a computer for taking the notes. Factorial designs can also include non-manipulated variables as independent variables. A factorial design with non-manipulated variables can still be considered as an experiment as long as at least one another variable is being manipulated. It is important to note that we can only draw causal conclusions about the variable we manipulated. Let's move on to the next topic. How would we present the data of our experiment? Usually, the results of factorial experiment can be plotted by representing one independent variable on the x-axis and another one by using different colored bars. You can plot any independent variable on x-axis, whatever suits more to your results and hypothesis. Dependent variable is usually being plotted on the y-axis. you can see how the data of our hypothetical experiment can be presented. In factorial designs, there are three kinds of results that are of interest: main effect, interaction effect, and simple effects. A main effect is the effect of one independent variable on the dependent variable, averaging across the level of the other independent variable. There are as many main effects as independent variables used in experiment. Again, in our hypothetical study, there is two main effects. The main effect of type of note-taking and the main effect of the time of the study. An interaction effect is when the effect of one independent variable depends on the level of another. Let's use our example once again. It can be that the effect of type of note-taking on learning effectiveness depends on the time of the day. Hypothetically speaking, there is no difference in learning efficiency between two types of note-taking in the morning. But in the evening, students who use computer for note-taking will study less efficient. The effect of one independent variable can depend on the level of the other in several different ways. The first possibility is spreading interaction, is when an effect is present in one condition but absent in another. In our hypothetical study, students who use computer for note-taking are more efficient in their studies, but only if they study in the morning. The second type of spreading interaction is when an effect is present in one condition is reduced in another. Again, in our example, students who use a computer for note-taking are more efficient in learning than the students who use paper and pencil, especially when they study at the morning, and way less when they study in the evening. Third possibility is when an effect that is present in one condition is reversed in another. For example, the students who use a computer for note-taking study more efficient when they study at the morning, and students who use paper and pencil study more efficient when they study at the evening. Researchers should not always trust the main effect. Some cases, main effect can be misleading, especially in crossover interaction. In our case, if we average across the conditions, we will get no difference for using paper and pencil or laptop for note-taking. In this case, it makes more sense to look at the simple effects. Simple effects are effects in each single condition. In our case, there is 4 conditions, meaning there should be 4 simple effects.